Hi, everybody. So I'm going to start. My name is Jonathan Ding. I'm working for Intel. I'm located in Shanghai, China. So I just traveled here for this conference. Okay. So basically, the problem we try to resolve for this project I'm going to introduce is for the real world problems that when we create IoT applications, we basically think in most of the time, application in IoT world could be modeled as an end-to-end application. That means it needs to be consist of services from the device side and also services from the cloud side. The problem for a typical software developer is that for these two kinds of services, they are distributed here and there because for cloud they are they are remote, and for some device, if you model that as a service, it's actually located locally. And sometimes these kind of services are not provided by you. So it means it could be heterogeneous. It is provided by others. For the device, it's kind of dynamic because it could be online and then maybe offline later. So this could be a very complicated problem for developers to resolve if they need the application eventually to be like mature and in high quality. So what we think is that maybe there is some possibility to help the developers with some tools or middleware to help them resolve this problem by providing a mechanism for them to create applications in minutes. So this is why we do this project. It's open sourced. Actually, I will show the URL later. And the short-term goal is that we hopefully, with a solution, then people could deliver the production quality applications in minutes. But in the longer term, we do think that when people creating the IoT applications, they have a development environment. And this development environment in most of the time is typically different versus what they are going to deploy. For example, you create your application for one home, and then you deploy that to other homes. Other home might have different appliances or smart things other than yours. So how to make this application developed for this one be workable for another, and they may exchange through an application store. These are kind of difficult problems we are going to resolve in the longer term. But in short term, we just help people to create that easily. In longer term, help them deploy that easily as well. I'm going to show a demo. Let's imagine a faked application. This totally doesn't make sense, but I just use that to show as an example. Suppose I have two sensors, temperature sensors. They could be located in the same room or maybe remotely different places. And if I measure them from time to time, if I get data from A and get the data from A, and if the temperature shows that it's greater than B, then I will turn on the fan. Otherwise, I will turn off the fan. So the application logic, it doesn't make sense anyway. If I need to create an application like this, basically for developers, they needed to do two things at least. First, they needed to create the business logic, the application logic for this, to fulfill this. Secondly, as an application, usually they should have a user interface. So typically in the past, you needed to do some HTML5, work by yourself, and use some RESTful API to show the data you measured from the sensors, etc. So I will show how we are going to do this by using the Okay. First, we do have a IDE fully programmed by HTML5. So that means you just need a browser instead of installing any kind of the software to your laptop or so. But anyway, just a browser. You will access this API, this IDE. Then you start from create applications. You could have multiple applications, but we just create a new one. We're starting from create some workflows. The left side is a payload that already have all of kind of the services located, displayed here. Some of them services are built-in service. For example, if you need to do some logical comparison, if you need to do some mathematics, these are so-called built-in services. Some services are from cloud, for example, Dropbox or Twitter, etc. These kind of or some cloud analytics services. Some services are added by the developers themselves. So I will show how they could add a service by themselves. Some services would be automatically discovered. For example, if that is OIC or whatever kind of the services have some description capability by themselves. So they could be automatically discovered and placed here. Basically, we list all of the services we know here. And for this simple demo, we do have the thermometer already discovered here. So I simply drag and drop them from the left panel to here. So basically, this is a workflow like, say, okay, it's too small, sorry for that. Basically, it says that, okay, I have a comparison service, and I have the temperature service. So I have 2 temperature sensors. So each is corresponding to one service. And eventually, I will do a switch on and off for fan. These are real services. So I will link them together. Say, okay, for the data sent from sent from this service, and this service they will be sent to the comparison to do a comparison. Then eventually, the result will determine the status of the fan. You may adjust the parameters of this, these services. Say, okay, for example, I will do some configuration. Say, okay, I need the sampling rate for this temperature changed from every 3 seconds to every 2 seconds. I will do these small adjustments. We will save that, and then we will start to create the user interface for that. The user interface is still in the same, IDE. We have a bunch of, UI widgets listed here as well. And we providing the specification so that the developers, if they needed to add more widgets by other than the default one, they could do that easily. For example, for this small application, we say, okay, we needed to visualize the data we collected from the sensors. So we have 2 gauges here, each for one sensor. Then we drag and drop some charts here to show the historical data of the sensor as well. We do have a fan control here, so to show the status of the fan. So we just save this now to say, okay, the end user interface will look like this. And then we will drag and drop these widgets we just created to this workflow as well. So now, this one is the UI widget we just drag and drop. It's a gauge. This is the chart. We said, okay, besides for the data collected from this service, from the temperature service, besides send to the comparison, we also send that to the UI widget. We just drag and drop. So this defines the data workflow. Okay, eventually that, and we. After all of these are done, we could execute the workflow. So this we show some real demos in here. But here is the user interface for the end user. They also do show the same state. So this is a demo we captured from the lab. Then for developers, they might need to do some debugging. Suppose I have some problem. Of course, for this demo, we didn't see any problem. But suppose you have a problem, see what have happened just now. So you need to check the messages exchanged inside the entire data flow. You could do a replay for the trace you just captured. For example, I do a replay now. Say, okay, so you will see for each stage, how is the data going through. You could do the single skate or multiple. Yeah. And finally, you could add the customized service by yourself. So you could add a virtual scene, add a thing here. And you can append multiple services around that. For this demo, we just create a simple Hello World demo, a simple Hello World service. We said, okay, you could describe what the service will look like. It takes one input and also have one output. You have multiple stages here for a service. It's called like a Java applet. You have like a initialization, cleanup, color. Color means that each time you are invoked, it will execute this code. And for this simple source code we just added, we just say, okay, for the input data you collect from you send it to an import, we just add like a temperature string as a prefix to that text and then output. So we just show how this works, okay? Okay, this is all about the demo. I will go back to the presentation. So basically what we demonstrated right now is first you could create a workflow. We didn't show that exactly in the demo, is that this is actually the workflow is very powerful. Besides the service side interest, it could be standardized or customized. We do allow you add more services here as well. And considering that you have a lot of services that takes multiple inputs, so this you will have a problem, so-called synchronization. So we do allow you to do some customization through UI. Say, okay, for example, for this comparison, you have 2 imports. Would you like to have a comparison every time you receive a message in either port, or you should wait for both ports have a new data, then you do the comparison? These are 2 different kind of behaviors, and sometimes you need this for one particular scenario, but sometimes you need another behavior. So we do allow developers to customize how they would conduct the actual operation based on what kind of pattern of the data they received. So they have multiple, visualized way to do this as well. And for service here, there is also a so-called binding mechanism. This is serving for our long-term goal. Means that when you drag a service here, it actually considers 2 parts. The first part is like an interface. Say, okay, I will use this service. The second part specifies during the execution, actually which service provider would be selected to access this service. So actually, when I show this demo, I drag a temperature service here. It just say, okay, I have a service here will be used, which is have 1 input and 1 output. It follows the specification like OIC night or whatever. This kind of the specification interface looks like this. And then I attach another kind of information. Say, okay, the device ID would be 1.2.3. And during the execution, it will say, okay, I need this service. I will query the service database, see, okay, any kind of the real service matches this. So this helps a lot. For example, you could deploy that in this environment, but later you change to another environment. You just only need to change the binding mechanism. So this binding could be a device query, or a fixed ID, as I mentioned, or it could be a dynamic JavaScript function. Okay, the UI I just mentioned. All of the UI widgets, we are treated them as just like a virtual IoT thing. Its behavior is same like a sensor or like a actuator, so you could do that with workflow. And the end user would see the physical thing also with the end user interface you just created. And you could add the new customized services. So basically, put that in short, we just create a thing like a layer. It consists of three quick keywords. The first is the middleware. That is try to normalize all of the existing hardware, physical UI widget, or remote cloud, all of these kind of things, to something you could program. Then the distribute means that you only need to draw a line between this service and the other service, but how these messages are exchanged on the line are totally transparent for the developers, because the remote communications are handled by the middleware instead of by the developers. For example, if you need a Node.js or whatever other kind of app programs, you need to explicitly say, okay, I'm sending an MQTT message, I'm sending maybe a co-app message. However, this isn't needed in this tool, because you just need to tell them, okay, which kind of the available data worker protocols you have, and the middleware will help automatically discover that for you and do the underlying remote communication. So you need to carry that kind of details. So yeah, okay, and the web ID, as I mentioned, we put visual programming. So FBB is a new concept. So we see that, for example, the Node.js and the Node.flow, we inspired by them a lot from the concept and the UI. But basically, we are create a lot of differentiations to make them suitable for creating IoT application. As I mean, first we said that we call that as holistic, because you have multiple component services here and there. We hide the underlying remote communication for you. And secondly, you could do a UI as a batch, so you didn't need 2 kind of developers, one for IoT domain, the other for the HTML5 domain. You just needed to have the knowledge to drag and drop. So this is the way we try to make the UI program easier as well. Third, the workflow engine is extremely enhanced. We try to add the dynamic binding, so you could change the service providers without changing the workflow by themselves. You could configure a lot of things like the data pattern, how you will consume the data. If you have multiple imports, you need them to do them for the batch, or you need to take operation for any message you received. We have the trace and a lot of, we are going to add a lot of debug capability in the future as well. So you could directly debug the JavaScript as well. So currently you could debug the workflow, see what happens inside the workflow. And the more are in the development stage as well. The basic architecture, I'll go that quickly. We have this layer like, for the underlying gray one, this is provided by existing environment. This is untouched, like the physical device, like Arduino, like maybe a cloud service. But you do have like an endpoint. We call that a service hub. It's deployed on like a simple small machine, and it manages the local resources they have, local services they have. So they normalize them to the services that could be regulated by the orchestration center. The center actually deploys the workflow, the web server, and all of the stuff they needed to manage the services and the workflow. Okay. So considering this deployment model, you could do multiple things for multiple deployment options for different scenarios. For example, for the smart home vertical, you could handle the endpoint. We call it the service hub in one particular room. For example, you could have a service hub for one room, and you have another for another room, and then you have a room gateway, or you have a cloud service remotely to serve as an orchestration layer, orchestration center. And you again, you don't need to know how take care about how they communicate with the messages by your program. You just need to configure, say, okay, they may be using MQTT, they may be using zero-man queue, they may be using some others. The middleware handles the remote configuration for you. And for the smart building, you maybe have the service hub for each room, and you have an orchestration center to run the workflow inside the building or running on top of on a cloud. And for the smart transportation, you maybe have the service hub to manage the local services, local hardwares for each vehicle, but you have the center located in the cloud to manage the workflows. So you actually have different deploy options, because for each hub, service hub, and also the orchestration center, they are simply a Node.js process. So you could distribute them, deploy them in any kind of the platforms that are supporting Node.js. Okay, this is the status that we have. We have open source with BSD license in GitHub. It's currently 0.9 because we are still having a lot of work in preparing the documentation, samples, and we are doing some building services and UI widgets already, but we are keep adding more. And we already have some protocols added, but we are going to add more. So this is basically what is essential for the 1.0 release that will happen by end of this year, hopefully this month. And we are also working with some open hardware companies in Asia to so that in the future they could currently they are selling some like hardware kit. It contains like maybe 10 sensors and 10 actuators, but no software there. They just say, okay, you use Arduino, and you create an application by you need to do that by yourself. So we are going to release a total solution that you contain the software and the hardware together. So all of this hardware already enabled for this software. So you just need a drag and drop to form a application by yourself. And we have planned for the next year as well to keep adding more features, but more focused on individual verticals. For example, we will address what is needed for the education, what is needed for the smart home. We will do that one by one for each vertical in later releases. So yeah, okay, I'm working for intelligence. This is my email box. I have like 2 minutes for questions. Any question? Yeah.
So what type of devices do you currently have support for? Does it just generically work on any device that can run Node? So say I had a Raspberry Pi,
yeah,
it would work on that theoretically? I mean,
yeah, great question. So actually, we didn't care too much about which kind of services or hardware here. We just added the support to this service here as well. So for container, we just add a generic device like and then if you have a GPIO stuff, this kind of and but if you have some proprietary or special stuff by yourself, you just need to add like a protocol plugin or whatever here to enable them. So the rest of stuff unchanged.
So it's basically just become platform agnostic, and now you just have this layer of
to shim them.
It knows, it shims
Yeah.
and knows exactly how to talk to the hardware on the line.
Yes.
That's cool.
Yeah. Thank you. Any other question? Sorry.
In the back end for your analytics, what are you doing?
So sorry, I didn't capture.
To handle the analytics in the back end,
Uh-huh.
how you are processing that?
The lyrics?
Analytics.
You mean in this layer? Data collection?
I think it would be the next layer.
Okay.
I mean, if I was like, do we have something like a patch, Spark, or something of that nature to analyze analytics of big data?
We didn't encounter that at so far, so.
So the analytics you have there is just temperature greater than temperature.
Yeah.
It's a simple situation.
Uh-huh.
But when you have more complex situation and you have more volume of data pouring in,
The problem is that if you have a data object, it just could be modeled as multiple fields. And the service we designed here, it could have multiple inputs and multiple outputs as well. So if you have a complicated object, say you have 10 fields, you could have a service that have 10 outputs. You could send data from each part. So visualize the data flow. It's not saying, okay, I only have one output. You have to encapsulate your data into a big object. You don't need to do that. I'm not sure whether this somehow.
So you're wondering how, so if you have multiple outputs coming from your device, whatever that be, how would you handle those outputs coming from?
you have a large volume of data.
Yeah, so say I have a big JSON object coming in.
And you need to scale orderly, and you need to be able to describe those analytics.
Well,
So that it's basically
yeah.
or Apache Spark sort of problem.
I think what he's saying is for each of those elements of that big data object you're getting back, you would be able to have a granular control over what outcome it drove. So you could drive your data operation once the data has reached the application layer here based off of each input is what it seems. Because each of these pieces coming out from the hardware is driving some decision maker. So you could tie each of your data attributes coming in as that big bulk data piece.
Okay. So thank you. We can discuss offline.
Okay.
Yeah.
All right, thank you.
Yeah, sorry.
I think that's kind of what you're doing.
Thank you. Yeah, thank you.